Hey there, class. Mr. Plusky here. Hope you're having a good day so far. We're continuing with 5.2. This whole section or whole chapter is about quadratic functions, and today we're talking about solving quadratic functions. So yesterday or the day before, well, day one, I guess, was all about factoring and the different types of factoring from Algebra 1. And so today we're going to be talking about taking that property, or taking that process, I guess, and actually solving. And so we solve quadratic equations when they're equal to 0. We're looking for the solutions for lines are points that are on the line. The solutions for quadratic functions are the x-intercepts. Okay, it's where it crosses the x-axis. So if you have, for example, a parabola like this, these would be the solutions, and that's when y equals 0, basically, for this parabola. Okay, so that's kind of what we're talking about today. It's going to be exciting stuff, and let's get into it. So a very important property that allows us to be able to solve quadratic functions is the zero product property, or ZPP, some people call it. And the property says this: let a and b be real numbers or algebraic expressions. If a times b equals 0, then a equals 0 or b equals 0. Right? Does that make sense? So if we have two things multiplied together, the only way to get 0 when we multiply two things is if one of the two things is 0. They can either be 0 or both of them can be 0, but that's the only way to get 0 when we multiply two things together. One of them has to be 0. So that's what we're going to do here. So let's go ahead and get into it now. So this is going to involve, we're going to be factoring like we were doing in the previous lessons, and then we're also going to take each of those parts. So for example, you factor and you get something like x plus 2 times x minus 8 equals 0. You're going to set x plus 2 equal to 0, or x minus 8 equals 0, and you're going to solve that. So the answer for this one would be minus 2 plus 8 plus 8. You're going to get x equals negative 2, or x equals 8. Those would be the solutions to this thing. And they're also the intercepts, an intercept form of in factored form, that is, of a parabola, or of a quadratic expression. So we got to factor first. So let's take a look at this here. Let's go through our steps for a factor flow chart. So we have x squared minus 3x minus 18 equals 0. First things first, do we have any GCFs? Well, this is a 1x squared, and this one does not have an x, so this is not going to be a GCF. How many terms do we have here? Well, we have 3 terms, x squared, 3x, and 18. Is it a perfect square trinomial? Well, this is a perfect square, but is 18 a perfect square? Nope, it is not. Perfect squares are like 16 or 25x or y squared to be 5y be the square root. Okay, it's anything you take the square root, it comes out to a nice perfect kind of thing. All right, so it's not a perfect square trinomial, which means we're going to go ahead and we're going to factor this by using the smiley face method. So we need factors of x squared. Well, that's kind of nice. It's going to be just x and x, and we have a negative and a negative here, which means what we need is we need a positive and a negative to multiply to negative 18. So we need a positive and a negative. I can put it either way I want because these are both the same. They're both x. All right. And then we need to figure out numbers that are going to multiply to negative 18 that are going to add to negative 3x. Well, it's going to end up being more negative, so we want to pair the negative number. Let's find the factors of 18. So we have negative 1 times 18, or the reverse of that, negative 2 times 9. Negative 3 times 6. And then when do you stop when you're doing factors? Well, you stop when you start going from here to the other column, basically. So the next thing after 3 times 6 would be negative 6 times 3. You see how that's the same thing, just flipped around here? Right? That's where you stop. So there's 3 pairings of factors that are going to work for factors of negative 18. So we need things that are going to add to negative 3x. Okay. Also, so I guess we would have 1 times negative 18, 2 times negative 9, and 3 times negative 6. Oops. So which pairing would work? Which pairings are going to add up to negative 3x? Well, let's try negative 6 and positive 3. Equal to 0 over here, too. So that's going to be 3 times x is 3x. So we get 3x, negative 6, negative x, or sorry, x times negative 6 is negative 6x. That equals negative 3x. We found the right thing here, okay? That's just factoring from before, but now what we're going to do, we're going to take this, we're going to keep that equal to 0 over here, and now we're going to take each part. This is like a times b, either a equals 0 or b equals 0, so we're literally going to do, we're going to do x plus 3 equals 0, or x minus 6 equals 0. And then we're going to solve these separately, and that's going to be our solutions. So how do I solve x plus 3 equals 0? Well, I subtract 3 from both sides. So I get x equals negative 3. How do I solve x minus 6 equals 0? Well, I add 6. So we're going to get x equals 6. So our solutions are going to be x equals negative 3 and x equals 6. Those are going to be where the parabola crosses the x-axis. Okay? All right, let's do number 2. Number 2 is a little bit tricky because it needs to be equal to 0. Is it equal to 0 right now or no? It is not. How do we make it equal to 0? Well, I can move this negative 20 to the other side here and make it equal to 0. So what are we going to do to move the negative 20 over there? To move stuff from the left to the right, we usually add or subtract. So what am I going to do? Well, I'm going to add 20 to both sides. Now, is the 20 going to go with the m squared or with the 12m or go by itself? Hopefully you said by itself because it is not like terms with m squared or 12m. So we're going to do plus 12m plus 20 equals 0. Now we have it equal to 0, which is very important for solving quadratics. And so now we can factor this and do our zero product property, okay? So, is there a GCF? No GCF. How many terms do we have here? We have 3 terms. Is it a perfect square trinomial? Well, 20 is not a perfect square, so it is not. So we're going to do our general factoring or our smiley face method. Oops. Equals 0. Okay, so we're going to do m squared. Square root to that is just m and m. Factors of 20 that are going to add to, so we got 1 times 20, we got 2 times 10, 4 times 5, and then 5 times 4, that's it. These are the factors of 20. So we need things that are going to add to 12. Well, we can see that 2 plus 10 is going to equal 12. Plus 2 plus 10. All right, so now we have it factored, and now we can set each part equal to 0. So we're going to have m plus 2 equals 0, or m plus 10 equals 0. How do we solve that from there now? What do we do? Subtract 2, subtract 10, m equals negative 2, or m equals negative 10. And that's going to be our answer. Those are the solutions for this quadratic equation. Okay, moving on. Next thing we have is intercept. It says review from section 5.1. So we have intercept form of a quadratic function. Do you remember what that was? It was a times what? X minus p times, what's the other one? X minus q. And the intercepts are going to be p and q. The numbers p and q are also called solutions, like we talked about. Those are also called solutions of the function. And it says write the equation in intercept form and then determine the function's zeros. Okay, well, we're going to fill in the box here is we're going to factor set equal to 0 and solve. Factor set equal to 0, and then you're going to solve. That's how we solve these kind of problems here, okay? All right, looking at number 1, we have y equals 2x squared minus 10x plus 12. So first things first, we need to factor this. We need to look for a GCF. Is there a GCF for these problems here? Well, these are all even numbers. Remember, the GCF, it can't be bigger than the smallest number. So the smallest number is 2. And the factors of 2 are 1 and 2, so it's either got to be 1 or 2 that we can divide these both by. Well, these are all even numbers, so they're all going to divide by 2. So we're going to do y. We're going to pull out a 2 in front. This one doesn't have an x, so we can't pull out an x. So we're going to have 2 parentheses. We got x squared minus 5x, dividing everything by 2, plus 6. All right, so we pulled out a GCF. Now we need to see how many terms we have inside the parentheses there. We have 3 terms. Is it a perfect square trinomial? It is not. Okay, so then we need to do our general factoring or our smiley face methods. We're going to do 2. We're going to make our brackets here like this. Factors of x squared are going to be x times x. This is negative, but we have a positive here, which means we have to have 2 negatives to give us that. So what are the factors of 6? So that's going to be negative 1 times negative 6, negative 2 times negative 3, and those are the only combinations. So which of these are going to add to negative 5x? Hopefully you said negative 2 and negative 3. All right, so we factored it. What's the next step? Well, we set the y equal to 0. The solutions are where it crosses the x-axis at y equals 0. So let's rewrite the rest of the problem for now. Okay. So now we need to go ahead and solve for each part here. We don't need to worry about the 2. The 2 is kind of its own thing. We only want to worry about stuff where there's an x. That's what we're going to set equal to 0. We're not going to set 2 equal to 0 because that doesn't make sense. 2 does not equal 0. We can't do anything with that. But we're going to set each binomial, I guess, or each factor equal to 0. So we're going to do x minus 2 equals 0 or x minus 3 equals 0. All right, solve that now. What am I going to do? I'm going to add 2 to both sides. I'm going to add 3 to both sides over here. And our answers are going to be x equals 2 or x equals 3. Those are going to be our solutions to this problem. Okay? So if you were to graph this parabola here, they would cross the x-axis at 2 and 3. All right. Moving along. We got 2 and 3 now. All right, we have y equals 5x squared minus 30x. First things first, do we have a GCF? We got to factor this. We do. We have a GCF. So what number goes into 5 and 30? Well, 5 goes into both 5 and 30. The factors of 5 are 1 and 5, and we can pull out a 5. If we pull out an x as well, we have x squared and we have an x. Which one's smaller, x squared or x? X is smaller, so we can pull out just a 1x. Now we got to divide these all by 5x. So 5x squared divided by 5x, x squared minus 2 minus 1 is going to be just x. And then negative 30 divided by 5 is negative 6, and the x's are going to cancel. Okay. Now let's go over here. So now we're going to set each thing with an x equal to 0. So we're going to set this equal to 0 and this equal to 0, and then we're going to solve. So we're going to have 5x equals 0 or x minus 6 equals 0. How do we solve for x now? What do we do? Well, we have 5 times x equals 0, so we're going to divide both sides by 5 over here. So x equals 0, and then over here we're going to add 6. X equals 6. So our solutions are going to be x equals 0 and x equals 6. All right, number 3, we have y equals 3x squared plus 17x plus 10. All right, factoring, is there a GCF? Well, the factors of 3 are 1 and 3. 3 doesn't go into 17 because it's a prime number, and 3 doesn't go into 10 either. Is there a exponent or a variable we can pull out? This one doesn't have an x, so that's a no. How many terms do we have here? We have 3. Is perfect square trinomial? We got to check that. This is not perfect square trinomial. This is not a perfect square. This is not a perfect square. So now we're going to do our general factoring, or smiley face method. So we need factors of 3x squared. Well, that's got to be 3x times x. Those are the only factors that work. These are all positives. We can know they're going to be all positive, which is great. And now we need factors of 10 that are going to give us 17x when we do this. Well, we got 1 times 10, 2 times 5, and that's it. So what should we put where to end up with 17x in the middle? Well, 17x is kind of a big number. Usually when we have smaller numbers, it means they're kind of close together. This one's not that close together, so what I'm going to do is I'm going to put the 5 right here to match with the 3x to give me 15x, and I'm going to put the 2 right here. Let's see how that works. Well, 2 times x is 2x, and then 3x times 5 is going to be 15x. 2x plus 15x is 17x, so that's the correct answer. So now we're going to set it equal to 0, and we're going to solve. Okay, so now we're literally going to take each part and set it equal to 0. So we're going to do x plus 5 equals 0. How do we solve that? Always subtract 5. X equals negative 5. And then we have 3x plus 2 equals 0. Okay, so this one's a little trickier. How do we solve this? Well, we got to get the 3x alone, so we're going to subtract 2 from both sides. Then we're going to get 3x equals negative 2. How do we solve for x now? We got to divide by 3. So our answers are going to be x equals negative 5 and x equals negative 2/3. And there's our solution. All right, now we're bringing it to kind of a trickier kind of idea, but it's really the same principles. We're just going to be using it to solve like kind of a word problem, I guess they're kind of word problems, not really, but they're application problems, I would say, is a better way to describe these. So we have the formulas for area of a rectangle, a triangle, and a trapezoid in a circle. And so we're going to be using that information in the diagram here and the formulas to be able to solve for different lengths and widths and stuff, okay? So we have a rectangle. The area is 112 meters squared. And we have, this is going to be the width. It's the short side. This is going to be the length. So we're going to be solving for the length and the width again, but this time we have the length and width is like x plus 5 and x minus 4. It's not just like x and 2x minus 1 or whatever, okay? So we're going to have to do some factoring and stuff here. So what's the formula for area of a rectangle? Well, it's length times width. So let's go ahead and just fill in what we know here. So area equals length times width. Well, the area is 112. The length is x minus 4. And the width is x plus 5. Did I get that right? I flipped those around, sorry. Let me fix those. So the length is x plus 5, and the width is x minus 4. All right, so now we're going to have to solve for x. And so in order to do that, we need to FOIL, and we need to make it equal to 0. So let's go ahead and do that first. We're going to double distribute here. So we're going to do x times x and x times negative 4. So 112 equals, that's going to be x squared plus, or sorry, minus 4x. Then 5 times x and 5 times negative 4 is going to be plus 5x minus 20. Okay. Combine like terms, we got 4x, negative 4x and 5x, so 112. What was that? That was weird. $112 equals x squared. Negative 4 plus 5 is plus 1x minus 20. All right, we're almost close. Now we're almost close to factoring here, but now we need to make it equal to 0. So I'm going to subtract 112 from both sides. Subtract 112 from both sides. We're going to get 0 equals x squared plus x, and that's going to be minus 132. Okay? So now we need to do some factoring. Now we can factor it because it's equal to 0. So is there a GCF? Well, this is a 1. That's not going to work. This one doesn't have an x, so no GCF. How many terms? We have 3 terms. Is it a perfect square trinomial? It is not, because 132 is not a perfect square. So we got to do our regular factoring. So we're going to do this stuff right here. We got x and x. We got a plus and a minus because it's negative 132. So we need the factors of 132, which are going to be negative 1 times 132, or the reverse, negative 2 times 66. So all I'm doing when I'm finding these factors is I do 132 divided by 2, then divide by 3, then divide by 4. And I just keep working my way up until I get to a point where they start repeating, right? Negative 4 times 33, negative 6 times 22, negative 11 times 12. And then you can see if you go again, it would be negative 12 times 11. Well, that's the same thing, just reversed to this one, right? So that's where we're going to stop. Okay, and so the factors that are actually going to work, that are really close to being, this is a 1x in the middle here, which is a very small number, so these numbers have to be pretty close together. So we're going to pick these two numbers because they're very close together. So we're going to do minus 11 and plus 12. So that's going to factor correctly. That's going to be positive 12x minus 11x is going to be 1x, which is great. So now we're going to go over here. We're going to set them equal to 0. We're going to do x plus 12 equals 0. And x minus 11 equals 0. Go ahead and solve that by subtracting 12, adding 11. So we get x equals negative 12, x equals 11. So those are the answers, but let's think this through a little bit. Could x be negative 12? Well, if you do negative 12, that'd be negative 12 plus 5, which equals negative 7. Can we have a negative 7 length or no? So sometimes these answers are going to be kind of not, they're not going to be real when we're working with actual like distances. So we can actually exclude x is not going to equal this because it's going to give us a negative answer. So we're going to take this 11 and we're going to plug it into these equations here. So the length was 11 x plus 5, so 11 plus 5, which is going to equal 16 meters. And the width is 11 minus 4, or x minus 4, which equals 7 meters. And there's your answer. That's how you do it. Okay, let's do number 2 now. I'm going to do this on the next page here. Hopefully that's an option for you. If not, I apologize. So now we have so we're looking for the area of a triangle. We're using the area of a triangle to solve for the base and height. So it's going to be, you can do either 1/2 base times height, or you can do area equals base times height over 2. I prefer this one. This is the one I prefer the best. So I'm going to stick with this one for now. So the area we know was 80. The base was 3x plus 1 based on the diagram up there. And the height was 2x. This is all over 2. Okay? So now I need to distribute this 2x to both of these because we're multiplying. So we're going to get 80 equals, that's going to be 2x times 3x is 6x squared. 1 times 2x is positive 2x. Divided by 2. Okay. Now we need to divide both of these by 2, so we're going to get 80 equals 6x squared divided by 2 is going to be 3x squared. 2x divided by 2 is going to be positive 1. Or just 1x, that is, just positive x. All right, now we're really close, so we simplify as far as possible. We could factor this and pull out an x and do x times 3x plus 1, but that's not going to help us. We want to keep it, I would keep it in standard form when you're trying to solve these. So you see how we have 3x squared plus x. I would not factor out a GCF out of this one right here, okay? And the reason why is because we need to get it equal to 0. So if we factor this, we're still going to have to like move this over here anyways and then factor again. So might as well just do it once at a time, you know what I mean? So what I would do is subtract 80 from both sides. And then we can factor after that. So we're going to get 0 equals 3x squared plus x minus 80. All right, now we need to go ahead and find factors of, we need to do a GCF. Is there a GCF that goes into all of these? No. How many terms? There's 3. Is it a perfect square trinomial? Well, 3 and 80 are not perfect squares, so that's a no. So we're going to go ahead and do our smiley face method. 3x and x are what it's going to work here. We have a positive and a negative here, so that means we're going to have to do positive and a negative, but we're not sure what it's going to be. So let's find the factors of negative 80. Well, that's going to be negative 1 times 80, negative 2 times 40, negative 4 times 20, or the reverse of these, negative 5 times 16, and negative 8 times 10. Okay, so lots of different options to try for this one. If you do it correctly, though, you should get 3x plus 16 and x minus 5. And there's just not really like a trick to this. You just kind of have to guess and check until you get something that works. It needs to add up to be a 1x in the middle here, which is kind of tricky. Usually I would pick things like negative 8 and 10, but it doesn't work for this because we have a 3x and an x. But yeah, these are going to be the options that work. But you have like 2 different combinations for each of these here. It could be up to 10 different combinations here that would work. But just take some patience and some finessing this kind of stuff. All right, so now we got to solve this. So we're going to set each part equal to 0. So we're going to do 3x plus 16 equals 0, x minus 5 equals 0. Solving for x, we're going to subtract 16 from both sides over here. 3x equals negative 16 divided by 3. X equals negative 16 thirds. Add 5 over here. X equals 5. Now, which one are we going to use, do you think? Well, we're talking about a distance again, so it doesn't make sense to have a negative 16 thirds distance, so we're going to use x equals 5. So let's go back up to the top over here. So x equals 5. And so the base was 3x plus 1, so 3 times 5 plus 1 equals, it's going to be, I'll go back to my page here, 15 plus 1 equals 16 centimeters. And the height is 2 times x, which is 5, so 2 times 5, which equals 10. And there we go. That's our answers. These are pretty tricky, so we'll do the best we can. We'll probably have some more examples like this and see how we do. But thank you for watching. Have a great day. We'll see you soon.